When we're talking about optical multiplexing, one of the first things that pops into our mind is CWDM or DWDM. But did you know that there's also something called MWDM? If you want to find out what that is, stick around and we'll check it out. Historically speaking, DWDM came first, and it is located here in the C-band area. Now the point is that the channel spacing of DWDM is so narrow that it actually requires an active cooling of the lasers in the transceivers to make sure that it wouldn't drift outside of the channel spacing window. And that actually made DWDM quite expensive. At least at the time it was really expensive. And that's why CWDM was specified. And as you can see, CWDM has a much broader channel spacing. As a matter of fact, the 20 nanometers of channel spacing is roughly 25 times that of a DWDM channel. And what that made possible was that you could use uncooled lasers, so making CWDM really a nice cost-effective solution. Now with the rise of 5G, new requirements came about, and the requirements were for a WDM solution for 12 wavelengths. It needed to be possible to cover a distance of at least 10 kilometers. Per wavelength you needed to have 25 gig, and it needed to be really, really cost effective. So, and the solution for that then was the so-called MWDM, so the medium wavelength division multiplexing grid. And how that came about was then instead of just taking any 12 of the CWDM grid, so any 12 wavelengths, it actually was a case that they focused on just the lower 6. And the reason for this is because the lower 6 CWDM channels were actually by far the most used channels, making them by far the most cost-effective ones compared to the higher CWDM channels. So we've got these 6 wavelengths, but as you can see, I mean, the math doesn't add up here. We haven't got 12 channels. So what they then actually did is they added a thermal electronic cooler, so a TEC, to the lasers again, making it possible to slightly shift the wavelengths, and then they shifted it by 3.5 nanometers to the left and the right of that original CWDM channel, resulting in, ta-da, 12 wavelengths. And because these lower 6 CWDM wavelengths are so cost effective, adding the TEC, so the cooler, actually still resulted in it being much more cost effective than using any of the 12 wavelengths. And the other advantage of using the CWDM, the lower CWDM channels, was that from a production point of view, pretty much all the production line could be reused to do the MWDM transceivers. So, in other words, MWDM is a very, very cost-effective WDM solution specifically designed for 5G mobile applications. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment and see you in one of the next videos. Bye-bye.